Alright, so this one says a proton has a kinetic energy of 6.8 times 10 to the 7 electron volts. What is the speed of the proton? So, if we were doing classical physics, Newtonian physics, you would use the formula K equals 1/2 mv squared. You'd have to convert that kinetic energy to joules. So you'd do 6.8 times 10 to the 7 electron volts times the definition of an electron volt being 1.6 times 10 to the minus 19 joules. Like that's the conversion between them. 1 EV equals 1.6 times 10 to the minus 19 joules. And then you would simply set that equal to 1/2 the mass of a proton times v squared, and you solve for v. I get v equals 1.14 times 10 to the 8 meters per second. Alright, but using Einstein's physics, you'd do it differently, and I just want to go over how that is different. So in Einstein's physics, if you have a proton that's moving with a kinetic energy of 6.8 times 10 to the 7 electron volts, you'd use a different formula. Formula is that E total equals the kinetic energy plus something called E naught. And so part of what Einstein did was he discovered relativity and showing the relationship between proper time and a dilated time. And then he showed the relationship between proper length and a contracted length. But he ended up basically propagating those ideas all through all of Newton's mechanics. And he arrived at this formula, which is very famous now, of E equals mc squared, showing that energy could be converted to mass and vice versa. But that E equals mc squared is actually going to be what's called the rest mass of a particle. And so a particle can have energy as mass, but that's going to be the energy that it has when it's at rest. It can also have kinetic energy, is the idea. And so the K term is the kinetic energy that it has. But it is relativistic. And then it can also have this E naught, which is called the rest mass. Alright, so E total has a formula as well, which is gamma mc squared. The gamma is the same gamma that we had used on relativity problems. So you can actually plug these formulas in to reveal this. Gamma mc squared equals K plus mc squared. Alright, so I'll just plug in everything that we have. Now, when we plug in the mass of a proton, we could plug in 1.6 7 times 10 to the minus 27. Okay, so this guy will be in kilograms. Then we'll do c squared. We'll do 6.8 times 10 to the 7 EV times the conversion of 1.6 times 10 to the minus 19 joules per electron volt. And then plus the mass of that proton. And then c squared. What I want to do now is just solve for gamma. The c is, of course, 3 times 10 to the 8th meters per second. Plug that in here and also here. Gamma is 1.072. Alright, then I would go to the formula for gamma, which is gamma is 1 over square root of 1 minus v squared over c squared. Plug in my gamma. Then we should be able to solve for v, which would be the relativistic speed of this proton, because it takes Einstein's mathematics into account. I'm getting that v is 1.08 times 10 to the 8 meters per second. 36% of the speed of light. And so you can see that the final speed, though, that it reaches here is not the same as it would have been if we had used Newton's physics. See up here, in Newton's physics, we said that it would be 1.14 times 10 to the 8th meters per second, which is different. Doesn't take into account that some of the energy is stored as mass for this proton. Alright, then if you wanted, you could go back and find out exactly how much of it was stored as mass and how much was stored as kinetic energy, right? So this is 1.08 times 10 to the minus 11 joules. And then you could also find out how much energy it has as mass. 1.5 times 10 to the minus 10 joules of energy as mass. Yeah.